Welcome to the online session conducted by Shriram Dandekar on behalf of DBJ College, Chiplun. We are studying applications of derivatives. In the last session, we have studied maxima and minima, the concept, and a couple of problems. Let us solve few more problems in this session. The first problem for you is find the local maxima and or local minima of fx is equal to x cube minus 6x square plus 9x plus 15 using the first derivative test. For this, first of all, let us recall what is the first derivative test. The first derivative test says that the function has maxima at x is equal to c if f dash c is equal to 0, f dash c minus h is positive and f dash c plus h is negative. Then we have maxima. And for minima, f dash c is equal to 0, f dash c minus h is negative and f dash c plus h is positive. This is for minima. Let us keep this in mind and solve this problem. Fx is given to us x cube minus 6x square plus 9x plus 15. Find out its derivative. F dash x is equal to 3x square minus 12x plus 9. Take 3 common. 3 into bracket x square minus 4x plus 3. This is equal to 3 into x minus 3 into x minus 1. For maxima or minima, f dash x is equal to 0 and therefore 3 into x minus 3 into x minus 1 is equal to 0 and therefore x is equal to 3 and or x is equal to 1. These are stationary points. Now for x equal to 3, if x is slightly less than 3, let us see what happens to f dash x. In that case, f dash x is equal to 3 into x minus 3 into x minus 1. Here we are assuming that x is slightly less than 3, that is, it is very near to 3. A number less than 3 minus 3, that gives you a negative number. Now, a number near to 3 minus 1 gives you a positive number. So, in that case, f dash 3 or left to 3, it is negative. So, the first condition, f dash 3 minus h is negative. Now, if x is slightly greater than 3, then f dash x is 3 is positive. Now x is slightly greater than 3, that greater than 3 minus 3 gives you a positive number, and number greater than 3 minus 1 gives you again a positive number, and therefore in that case you get a positive number, and therefore I can say that f dash 3 plus h is positive. Now see this definition. F dash 3 is equal to 0, f dash 3 minus h less than 0, and f dash 3 plus h greater than 0. So we get a minima at x equal to 3, and therefore by first derivative test x equal to 3 is minima. And minimum value is f of 3. It is equal to 3 cube minus 6 into 3 square plus 9 into 3 plus 15. That is equal to 27 minus 54 plus 27 plus 15. It is equal to 15. Now for x equal to 1, because x equal to 3 and x equal to 1 are stationary values, and therefore for x equal to 1, let us see what happens to f dash x. For x slightly less than 1, for x slightly less than 1, we get f dash x as the first number 3, it is positive. Second number x minus 3, x is slightly less than 1, it is near to 1, so this number is negative. And x minus 1, x is less than 1 minus 1, it is a negative number, and you get a positive value. 2 times negative gives you positive. So I can say that f dash c minus 1 minus h, f dash 1 minus h is positive. For x slightly greater than 1, we get f dash x equal to 3 is positive. Now number slightly greater than 1, but 1 minus 3 gives you a negative number, and slightly greater than 1 minus 1 gives you a positive number. So it is a negative number. This is negative number, and therefore I can say that f dash 1 plus h is less than 0, and therefore by first derivative test x equal to 1 is maxima. And maximum value of f is f of 1, that is equal to 1 cube minus, what is fx, x cube minus 6x square plus 9x plus 15, 1 cube minus 6 into 1 plus 9 into 1 plus 15. This is equal to 1 plus 9 10, 10 minus 6 is 4, 4 plus 15 is 19, and therefore the local maxima at x equal to 1 and the maximum value is 19, local minima at x equal to 3 and local minimum value is 15. That final answer you may write. The next problem is using first derivative test, discuss the maxima and minima of fx is equal to x minus 1 bracket cube into x plus 1 bracket square. We have fx is equal to x minus 1 cube into x plus 1 square, and therefore f dash x is equal to, I am going to use product rule and chain rule, x minus 1 bracket cube as it is derivative of x plus 1 square, 2 into x plus 1 into derivative of x plus 1 is 1, plus x plus 1 as it is, x plus 1 square as it is, derivative of x minus 1 bracket cube is 3 into x minus 1 bracket square into derivative of x minus 1 is 1. Taking x plus 1 into x minus 1 square common, x plus 1 into x minus 1 square common, inside the bracket there will remain 2x minus 2 here, and here 3 into x plus 1, that is plus 3x plus 3. This is equal to x minus 1 bracket square into x plus 1 into 5x plus 1. This is f dash x, and therefore f dash x equal to 0 gives stationary values. And therefore x equal to 1, x equal to minus 1 and x equal to minus 1 upon 5 are stationary values. We have to find out at which of these the function has maxima or minima or nothing, and we have to use the first derivative test. Firstly, x equal to 1. For x equal to 1, for x slightly less than 1, x slightly less than 1, f dash x is equal to, firstly x less than 1, this number will be negative, but its square is there, so it becomes positive. Second number is x plus 1, x is slightly less than 1, but 1 plus any positive number gives you positive quantity, and here also some number, positive number multiplied by 5 plus 1 gives you a positive number, that is you have a positive number. So I can say that f dash 1 minus h is positive. For x slightly greater than 1, f dash x will be, now greater than 1, that number minus 1 is a positive number, its square is positive, and the remaining two are also positive numbers, and here also you get a positive number, and therefore f dash 1 plus h is also positive, and therefore x equal to 1 is neither maxima nor minima. We say that it is point of inflection. Let us see for x equal to minus 1. For x slightly less than minus 1, f dash, I can directly write minus 1 minus h is, the first number is positive because it is a square number. Now a number less than minus 1 plus 1, it is negative number, and a number less than minus 1, that is negative number multiplied by 5, is less than minus 5 plus 1, it is a negative number. So positive negative negative gives me positive, and therefore f dash minus 1 minus h is positive. For x slightly greater than minus 1, f dash minus 1 plus h is, as usual, the first number being square is positive, whatever may be the value of x. Second number greater than minus 1, so greater than minus 1 plus 1 gives you a number positive, and third number, this is a negative multiplied by 5 plus 1 gives you negative number, and therefore f dash minus 1 plus h is negative. F dash minus 1 plus h is negative, and therefore by first derivative test, x equal to minus 1 is, towards left it is increasing function, towards right it is decreasing function, so it is maxima, and maximum value of f is f of minus 1 equal to minus 1 bracket cube into minus 1 plus 1 bracket square equal to 0. For x equal to minus 1 by 5, for x slightly less than minus 1 by 5, f dash minus 1 by 5 minus h is, the first number being square quantity is positive, second number slightly less than minus 1 by 5 plus 1, it is positive number, and third number is negative. So in all the result is negative, and f dash minus 1 by 5 plus h is, all the three numbers in this case are positive, and by first derivative test x equal to minus 1 by 5 is minima, and minimum value of fx is f of minus 1 upon 5, that is minus 1 upon 5 minus 1 bracket square, bracket cube, into minus 1 by 5 plus 1 bracket square. It is equal to minus 3, 4, 5, 6 upon 3, 1, 2, 5. This is the end of this problem. Next problem is, discuss the maxima and minima for the function fx is equal to sin raised to 4x plus cos raised to 4x. Here no method is asked, that is you can use here first derivative test or second derivative test. I always prefer the second derivative test over the first derivative test. Fx is given to us sin raised to 4x plus cos raised to 4x. Therefore f dash x is equal to 4 into sin cube x into derivative of sin x is cos x plus 4 cos cube x into derivative of cos x is minus sin x. Take 4 sin x into cos x common. Inside the bracket there will be sin square x minus cos square x. Equal to minus 4. I can write this as minus 2 into 2 sin x cos x into cos square x minus sin square x. Taking negative common and writing 4 as 2 into 2. This is because I want to use 2 sin x cos x is sin 2x, and also cos square x minus sin square x is the formula for cos 2x. Again minus 2 sin theta cos theta is sin 2 theta, so it is minus sin 4x. First derivative is here, second derivative is derivative of first derivative minus 4 cos 4x. Derivative of sin bracket is cos bracket into derivative of 4x is 4. For maxima or minima, f dash x is equal to 0. That gives me minus sin 4x is equal to 0. That means sin 4x is equal to 0. Now the given function is fx is equal to sin raised to 4x plus cos raised to 4x. I forgot to mention here, given in the problem, I forgot to write here 0 is less than x is less than pi by 2. This is correction, and this implies that 4x is equal to pi, and therefore x is equal to pi by 4. This value satisfies this 0 less than x less than pi by 2, and therefore x is equal to pi by 4. There are infinitely many values of x for which we get sin 4x is equal to 0, and therefore x is equal to pi by 4. Now f double dash pi by 4 is equal to minus 4 times cos 4 into pi by 4, that is minus 4 into cos pi. Cos pi value is minus 1, so this is minus 4 into minus 1, it is 4, which is positive, and therefore by second derivative test x equal to pi by 4 is minima for fx, and therefore fx equal to sin raised to 4x plus cos raised to 4x has minima at x equal to pi by 4, and minimum value of f is f of pi by 4, that is sin raised to 4 pi by 4 plus cos raised to 4 pi by 4. It is equal to 1 by root 2 raised to 4 plus 1 by root 2 raised to 4. 1 by root 2 raised to 4 is 4, so 1 by 4 plus 1 by 4, it is 2 by 4, it is equal to half, and therefore summing up the answer, minima at x equal to pi by 4 and minimum value of fx is half. Next problem is discuss the maximum and minimum values of the function fx equal to sin 2x minus x for minus pi by 2 less than x less than pi by 2. Fx is equal to sin 2x minus x for minus pi by 2 less than x less than pi by 2. Therefore f dash x is equal to 2 cos 2x minus 1, and therefore f double dash x is equal to minus 4 sin 2x. For stationary values, f dash x is equal to 0, and therefore 2 cos 2x minus 1 is equal to 0, and therefore cos 2x is equal to half. In the interval minus pi by 2 to plus pi by 2, cos 2x is equal to half for 60 degrees and minus 60 degrees, that is 2x is equal to plus or minus pi by 3, and therefore x is equal to plus or minus pi by 6. Now f double dash positive pi by 6 is equal to minus 4 times sine 2 into pi by 6, that is minus 4 into sine pi by 3. Sine pi by 3 value is root 3 by 2. This number is certainly negative, and therefore by second derivative test x equal to pi by 6 is maxima for fx, and maximum f is f of pi by 6 equal to sine 2 into pi by 6 minus pi by 6. Sine 2 into pi by 6 is pi by sine pi by 3. Sine pi by 3 value is root 3 by 2 minus pi by 6. Now f double dash minus pi by 6 is equal to minus 4 into sine 2 into minus pi by 6. It is minus 4 into sine of minus pi by 3. It is 4 root 3 upon 2 positive, and therefore f dash minus pi by 6 is 0, and f double dash minus pi by 6 is positive. By second derivative test x equal to minus pi by 6 is minima for f, and minimum value of f is f of minus pi by 6. It is sine of 2 into minus pi by 6 minus pi by 6. This is equal to sine of minus pi by 3 is minus root 3 by 2 plus pi by 6. This is the final answer. Next problem is divide the number 40 into two parts such that their product is maximum. Here maximum thing required is the product. Therefore write a function for product in one variable and take it to second derivative test. This is the basic thing we are going to do. We want two parts of 40. Let x and y are required parts, that is x plus y is equal to 40, and therefore y is equal to 40 minus x. Let the product P equal to xy. Therefore P equal to x into 40 minus x equal to 40x minus x square. Therefore dp by dx, first derivative is 40 minus 2x, and second derivative is d2p by dx square is equal to 40 derivative 0 minus 2x derivative is minus 2. Now for maximum or minimum p, dp by dx is equal to 0. Therefore now dp by dx is 40 minus 2x. 40 minus 2x equal to 0, and therefore 2x is equal to 40, and therefore x is equal to 20. Now d2p by dx square at x equal to 20 is minus 2, which is negative, and therefore dp by dx at x equal to 20 is 0, and d2p by dx square at x equal to 20 is negative, and therefore by second derivative test x equal to 20 is maxima for P. That is, the product is maximum when x equal to 20 and y is equal to 40 minus x equal to 40 minus 20 equal to 20, and therefore 20 are required parts. The next problem is a ball is thrown in air. Its height at any time t is given by h is equal to 3 plus 14t minus 5t square. Find the maximum height it can reach. H is equal to 3 plus 14t minus 5t square. Therefore dh by dt is equal to 0 plus 14 minus 10t, and therefore d2h by dt square is equal to minus 10. For maximum or minimum h, dh by dt is equal to 0, implies 14 minus 10t is equal to 0, implies t is equal to 1.4. 14 by 10, 1.4. Now d2h by dt square at t equal to 1.4 is minus 10, which is negative, and therefore dh by dt at h equal to at t equal to 1.4 is 0, and d2h by dt square at t equal to 1.4 is negative, and therefore by second derivative test t equal to 1.4 is maxima for h, and maximum value of h is h max equal to 3 into 14 into 1.4 minus 5 into 1.4 square equal to 3 plus 19.6 minus 5 into 1.96, it is 12.8. This is the maximum height the ball can attain. Units. Unit must be given. Final answer in words is expected from you. Thank you for today. In the next lesson we will solve the word problems on maxima and minima. Thank you very much.